From a distance, it's a beautiful blue marble, safe, familiar, home. This is the image we dream of when we look up at the night sky, a pale blue dot teeming with life, protected by a gentle atmosphere. We hunt through the darkness of the cosmos, hoping to find another, a mirror, a twin. 64 light-years away, in the constellation Vulpecula, another blue marble hangs in the black. From this distance, it looks just like home. It is a stunning, deep cobalt blue. But this planet is not a twin. It is a monster. This is not a story about finding new life. This is the story of the most terrifying planet we have ever found. A world where the winds move faster than a bullet, the air is hotter than lava, and it rains glass sideways. This is HD 189733b, and it is a nightmare.
Our story begins not with a telescope, but with a shadow. To find planets this distant, we don't look for the planet. We look at its star. We wait. We watch for a tiny, almost imperceptible dip in the star's brightness. This is the transit method. It's the shadow of a world passing between us and its sun. When astronomers first pointed their instruments at the star HD 189733, they saw this shadow, and they saw it happen every 2.2 Earth days. Think about that. Its entire year is only 52 hours long. This told us two things immediately. First, the planet was big, about 13% larger than our own Jupiter, a hot Jupiter they called it. Second, it was impossibly close to its star, far closer than Mercury is to our sun. It skims the surface of its parent star, locked in a permanent gravitational embrace. But the real shock came later. In 2013, astronomers using the Hubble Space Telescope didn't just see its shadow, they managed to measure the color of the light reflecting from its atmosphere.
The result was unambiguous. The planet was blue, a deep, rich azure blue. The scientific community was electrified. Blue is the color of hope. It's the color of water. On Earth, our blue comes from the oceans, from the way our atmosphere scatters sunlight, a phenomenon called Rayleigh scattering. It's the color of life. So what made this planet blue? Was it a vast global ocean on a world 1.13 times the mass of Jupiter? Was it a different kind of atmosphere that scattered light in the same hopeful way? The truth was far more alien. They pointed Hubble back at the planet, but this time they analyzed the light from the star as it passed through the planet's atmosphere during a transit. They were reading its chemical fingerprint. They found carbon monoxide. They found methane. And then they found sodium. But it wasn't the chemical itself that was strange. It was its signature. The signal was massive, indicating the sodium was being blown by an extreme, powerful wind. The blue, it turned out, was not the color of hope. It was the color of violence. The atmosphere wasn't scattering light like ours. The blue color was coming from particles. Billions upon billions of microscopic particles suspended in the air. The chemical analysis told us what they were. Silicates, the building block of sand, the primary component of glass. This wasn't an ocean world. This was a world with clouds of glass. And that was only the beginning of the terror. Let's take a journey to this place. But first, we must understand the distance. HD
189333b is 64 light years away. That's 376 trillion miles. If you were on the Voyager 1 spacecraft, our fastest moving object, traveling at 38,000 miles per hour, it would take you 1.1 million years to get there. So, let's break the laws of physics. Imagine a ship, our ship, one that can fold space and time, arriving in orbit in a matter of moments.
We drop out of warp, and the view is terrifyingly beautiful. The planet fills our viewport, a swirling tempest of cobalt and navy blue. It doesn't look like a gas giant, it looks like a polished marble. But the ship's external sensors are screaming. The first reading is the wind. Our ship is being battered. We are not in a storm. The entire planet is a storm. Astronomers measuring the atmospheric distortion of this planet clocked its winds. They are moving at 5,400 miles per hour. That is 8,700 kilometers per hour. Our fastest ever recorded tornado in Oklahoma, an F5 monster, had wind speeds of 300 miles per hour. This is 18 times stronger. The speed of sound on this planet is different than on Earth, but by any measure, these winds are supersonic. They are moving at Mach 7, 7 times the speed of sound. A bullet from a high-powered rifle travels at Mach 3. This is a permanent, planet-wide hurricane of winds moving twice as fast as a bullet every second of every day.
Then the second alarm, heat. The ship's hull is flashing red. The temperature outside is 1,800 degrees Fahrenheit, 980 degrees Celsius. This planet is tidally locked. Just as our moon only ever shows one face to Earth, this planet only ever shows one face to its star. There is a day side, trapped in a permanent scorching noon, and there is a night side, trapped in an eternal frozen darkness. On the day side, the atmosphere is so hot that lead, aluminum, and silver would instantly vaporize. But here's the mystery that puzzled scientists. When they measured the temperature of the night side, it was also incredibly hot, around 1,300 degrees Fahrenheit. The temperature was almost evenly distributed. How? The 5,400 mile per hour winds. The atmosphere is moving so fast, it physically drags the heat from the day side to the night side, creating a global, supersonic blast furnace. This planet doesn't have weather. It has one single, permanent, violent state of being. Now we are in the tempest. Our ship is shaking apart, and the external cameras are failing. The sensors are picking up impacts, billions of them. It's raining. But it is not raining water. Remember those silicate particles, the glass clouds? In this 1,800-degree heat, those glass particles don't stay solid. They melt. The atmosphere is filled with droplets of molten glass. And because of the 5,400 mile per hour Mach 7 winds, it is not raining down. It is raining sideways. This is the planet's weather. A permanent, global storm of supersonic winds, firing microscopic shards of molten glass in every direction. Anything caught in this atmosphere would not just be melted, it would be sandblasted, flayed from existence, scoured to atoms in less than a second. This beautiful blue marble is the closest thing to hell we have ever found. You might think this is the worst the universe has to offer, that this planet is a unique monster. You would be wrong. The cosmos is filled with nightmares. HD 189733b is just one wing of a gallery of terror. Let's look at the other contenders. If you travel 750 light years to the constellation Draco, you'll find TRES 2b. Scientists call it the Dark Planet. It's a gas giant, much like Jupiter, but it reflects less than 1% of the light that hits it. It is blacker than coal, blacker than acrylic paint. It is a phantom, a giant planet-sized hole in space, absorbing light in a way we barely understand. The only reason we see it is because it is so hot that it glows, a faint, dull cherry red like a dying ember. It is a world of eternal, burning darkness. But perhaps heat is more terrifying than dark. Then let us meet Kelt 9b. 670 light years away, this planet is so hot it redefines the word planet. Its dayside temperature is 7,800 degrees Fahrenheit, 4,300 degrees Celsius. This is hotter than most stars in the universe. It is so hot that its own atmosphere, the very molecules of hydrogen that make it a gas giant, are being ripped apart. The planet is literally evaporating. It trails a tail of vaporized gas behind it like a comet. It is a planet being actively executed by its own sun. It won't exist for long. It is a dying, screaming world, being boiled alive.
So why? Why in this gallery of horrors does HD 189733b haunt us? The dark planet TRES 2b is a phantom. The evaporating planet Kelt 9b is a victim. But HD 189733b is a traitor. Its terror is not in its heat, or its wind, or its glass rain. Its terror is in its deception. It fooled us. It cloaked itself in the most hopeful color we know, the color of oceans, the color of our sky, the color of home. It reminds us of the single most profound and terrifying truth of the cosmos. The universe is not for us. It does not care about life. It does not operate on biology or morality. It operates on physics. And physics, in its raw, unfiltered form, is a force of unimaginable violence. Physics creates the gentle 2.2-day orbit of this planet. And physics creates the 5,400-mile-per-hour winds that carry molten glass. The universe builds wonders, and it builds nightmares. And sometimes they look exactly the same. In 1990, the Voyager 1 spacecraft, 3.7 billion miles from home, turned its camera around one last time. It took a picture. Our world, a single pixel of light in a vast, dark sunbeam. Carl Sagan called it the pale blue dot. He wrote, "On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on a mote of dust, suspended in a sunbeam. We have searched for another dot. We found one, 64 light years away. But its blue is not the blue of oceans. It is the blue of silicate clouds. Its breeze is not a breeze. It is a supersonic sandblaster. The discovery of HD 819733b did not give us a new home. It gave us a warning. It taught us that our world, our gentle, safe,
blue marble is not the rule. It is the exception. But is it the only exception? We've shown you the nightmares. What other wonders are hiding out there? Let us know in the comments. What is the most mind-blowing planet you've ever heard of? We read every single comment. Thanks for watching.